yeah, processing was made to be a very easy way for artists and designers to get into programming. The website still looks a little terse, but this is going to change very soon. And let me see, I'm going to put this in the other screen. Yeah, no, that's perfect. So yeah, what was I saying? So yeah, so processing is really meant for designers and artists, and it makes it very easy to get started with creative coding. And so I don't know if you're gonna be following along or if I'm just gonna show you demonstrate a little bit. I usually prefer a code along, but this might not be convenient if you're watching this and you have only one screen. But I will also share a lot of resources after this lecture where you can go. Hmm? Sorry. That was
sorry, my mic was.
Okay, no worries. All good. So yeah, by the way, so I'm also running monthly meetups as a co-host of something called Creative Code Berlin, and we've been doing this since 2012, and it's a place for people who explore creativity with computer code. So yeah, if you also want to get connected with a community of people being creative with programming, you can also join that. And I also stream on Twitch, and I'll give you the links to all of that at the end. So what you can probably hope to learn today is, well, what is programming, what is coding, and more specifically, what is creative coding. All code is creative by nature. Well, the engineers will tell you that. But what we mean when we talk about creative coding is more of a label that a certain community of artists have gathered around and have claimed as a way to program not to fulfill requirements of an application or website that needs to do something specific, but more of an exploratory way to use code like you would use a pen or like you would use clay, using computer code as an artistic medium. And I feel like this is for many artists, at least it was for me, a better entry point, an easier entry point to coding. And yeah, we'll see that now. So the first step when using processing is to go and download it. I already have it installed, but you can download it for whichever operating system you're using. Typically, if you're on Windows, the 64-bit version is probably what you're using, unless you have an older machine. But yeah, you can download it for any platform that you want. And when you open processing, which I'm going to do right now, and before we start, do we have any questions or sort of demands, I was gonna say, but like wants or needs that you would like me to cover? Because this is gonna be a little bit of a loose introduction. I'm usually just coding along and responding to questions or specific needs that people have. Like if you're more interested in sound, we can talk about that. If you're more interested in interaction, we can talk about that. But yeah, we'll start from scratch, which is a window like this. And let me close the rest. So this is what you will see when you start processing for the first time. It's the editor. And here you can type some text, as you can see. You have what looks like a media player button here, like play and stop. The play button is actually the run button. That means it's going to run your program. And we haven't written a program yet, but we can still press the run button. And you'll see that what it does is it's going to open if it's if it wants to. Yes. Oh, wait, it opened it in the other window. That's going to be annoying. I hope this is... oh, can I move it? No, I can't move it. It's in the other window. It stays there. Uh-oh. Okay, interesting. So, but when you do this, hopefully the window will appear on your side of the screen. Let's see. Can I move it? Yes, I can. Okay. So it opens a small window here. It is sort of the default processing window. And you see it has this this beautiful default gray background and nothing else. So you can't do anything. It doesn't show anything, but it's still running. And that's for anybody who tried to learn programming before, maybe with something more like we say low level, so these very abstract kind of programming languages like C or C++. Typically, just to display a window, it takes a lot of code just to do that. And processing does all of that for you. You don't have to worry about it. You can just think about what you want to show inside of the window. So the way that that we do this is just by typing something like, let's say I want to draw a circle. There's no circle function in processing, or is there now? Let me check. I think there might be. So I need to write circle. That's a function. And a function is something that tells the computer what to do. So this is not enough. If I run this, I'm going to get an error. You see here, unexpected token. That sounds a little bit confusing, but it just means it doesn't understand what you're saying. So to make it understand what I'm saying, I need to give it some more information. And here you can see it gives me some help. Actually, it says the function circle expects parameters like float, float, float. So circle, parenthesis, float, comma, float, comma, float, close parenthesis. And what that means is there are 3 parameters that are of type float. And I know it might sound complicated, but all that means is it wants numbers from me. And those numbers mean something. And the way that I can know what those numbers mean is I can right-click on the function, on the keyword, and go to find in reference. And this is going to be your friend. Like that's going to be your best friend, find in reference for the rest of your life if you keep using processing. Because processing has a list of keywords that it understands, essentially. You can write anything you want in this window, but only specific words are going to be understood by processing as valid code. And if I click on find in reference, it shows up in my browser, a window with all the explanations of what those parameters, so information that the function needs to display something, what those parameters mean. Here I can see an example, circle with 3 numbers. And here, syntax means what those parameters mean. So x, that's here explained even in more details. The x coordinate of the ellipse float is the y coordinate. So x is, if you remember your math lessons, x is the horizontal axis and y is the vertical axis. So we're going to do that. And yeah, and extent, which is kind of a weird way to call it, that's the diameter. So yeah, they called it extent for some reason. All right, but it doesn't matter. I can just say I want to draw it at, say, 10 pixels from the left, 20 pixels from the top, and we're going to give it the size of, let's say, 15. That's the diameter. And you see that there is a little squiggly line here. And if I look at my my helper here, it says missing a semicolon. So every line of or every instruction that you give to your program needs to end with a semicolon. And now it's happy. It's no squiggly anymore. And I can run it. And as it shows it in the other window again. So yeah, here we have our circle here. That's great. So this is probably the simplest program that you can write in processing, besides an empty program that still runs. So here we're just drawing this circle here. That's wonderful. But you might be thinking this is not the most exciting thing ever, unless you've been trying to program before and gave up, because this is quite exciting actually. It's just working. So yeah, do we have any questions so far? That's advanced stuff. I've seen that we have mostly beginners, so I'm taking it very slowly. But if it's too slow, let me know, and I can go a little bit faster. But I really want to make sure that you understand the basics, because yeah, once you get like the very basic ideas of programming, you can go and learn by yourself. And because we have only 1 hour and a half, I think what the best we can do today is to give you the tools that you need to understand any other resources that you're gonna look up and find. And also, we can talk about this again next week when we start working with P5.js. All right. So no questions. Moving on. Or maybe there are questions. I don't know. Is there a delay? I'm used to the delay on Twitch, so usually the questions are coming like 30 seconds later. Yeah. So yeah, what can we do with this? So this is our circle function. We could draw another one. So if I was to write a second function and run it again, this is gonna mess me up. This this window that appears on the other screen every time. You know what? I think I know what it is, and I might be able to fix this quickly. I need to go in my display settings and change which is the main screen. So how do I decide which one is the main one? Make this the main display. Yes. Okay. This should work. Okay, let's try it. Run. No. Run. No, it didn't work. Okay, never mind. I'll just carry it over every time. Oh, it made it worse actually. Okay, just a sec. Haven't had this problem before. My apologies. We'll get back in a second. No, it's that's why. Okay. Yeah. All right. Never mind. Duplicate. Okay. I messed it up worse than it was before, but hopefully I can still make it work. Yeah. All right. Okay, so now we're drawing two circles, but actually we only see one. And that's because they're drawn on top of each other. So I can move this one a little bit. And now we have two circles. Okay. Is that clear so far? Can you hear from anyone? All good so far? We're still in the very basics. All clear. Okay, good. So, all right, thank you. So next up, we're gonna start with. So this so far is not very flexible. It's very simple, but I can't make this interactive because we're missing some key component in a processing program. Normally in processing sketch, we're called program sketches in processing. We're missing two key components. And those are, and I left them out on purpose because they're a little more complicated to understand, but typically every processing sketch that you're going to see in the wild or that you're going to make is going to contain those two things. And those are the setup function and the draw function. So I left them out because there are a few details that are that needs explaining. So the first is this keyword void. This is a return value of the function. In this case, you don't have to worry about it really. You will understand what that is in the future. Just for now, just consider that you have to write void setup and void draw. Then we have these squiggly brackets, which are basically telling us what is this function going to do. Setup and draw are also functions from processing, but they have a specific behavior that is defined by processing. And how processing is going to interpret these functions is so, first of all, the setup runs once when you press play, when you press the button. So it runs only once. And the draw is a loop. And what that means is it runs again and again. Runs again and again and again. And this about 30 times per second or 60 times per second, I'm not sure anymore in the latest version. That depends probably also on your display. So so we can show how this works. So here in the setup, I can do something. So we can do, and you see that this is not updating in real time. So if I make changes, I need to run it to stop this and run it again to see the changes. So here in the setup is actually where we can do something useful, which is I forgot how this works in processing because I've been using P5 so much. So create canvas in P5, but how is it in processing again? Oh, and you know what? What happens if you get lost like this? So if I get lost on basic stuff, another thing I can do, and this here, there's no find in reference because it's just set up and it's not gonna tell us anything. It's too basic. So I'm stuck in something too basic, and but there's a way out. I can go to where is it? To file, I believe. No, wait. So it's was there sketchbook examples. Yes, thank you. So in file, there's examples, and this is your second best friend. So the finding reference is your number one best friend, but your BFF. But examples is your second best. And what it is it contains a large amount of example sketches that you can open on any kind of subject. So say I want to see how to draw a shape. I can go there. Yeah, this is a bit too advanced. So say I want to understand color. So yeah, okay. Hue. I open this, and it opens the example. And there I found already what I needed. So this is a little more advanced sketch. We might end up with something like this. And I see its size. It's just called size. And that's going to define the size of our window. So we're going to do size and say 100 by 100. This is the size in pixels. So now if I run it, we're going to see that our window is, it's not bigger actually. Or I know it's because it's the default size is 100 by 100. So I'm going to run it again. Yes, okay. Also makes it easier to drag it around. So my favorite size is actually 600 by 600 because I remember Tumblr, and we're going to do it like this. Okay. So as you can imagine, we don't need to redefine the size several times. We only need to do it once. So we can, we do this typically in the setup, and that's what setup means. We set it up, we set everything we need. Maybe we want a background color, so I could type background, and what do you think background takes? So as parameters. So here we see, let's see if does it tell me something? Yeah, expects parameter is like background int. So int is an integer, so a whole number. But what do you think I should put in background? Any ideas? What kind of
Default.
values do you? Sorry.
I think RGB colors.
Yes, that is correct. So red, green, and blue. Because I mean, I'm not a doctor, so or a biologist, but our eye has specific cells that perceive red, green, and blue. They're not equally sensitive. Actually, I think we perceive blue better than green and red, or there's something, or maybe it's yeah. I think that's the one. But it doesn't matter. That's how pixels on the screen work. Nowadays, it's a bit harder to see the pixels. If you have a magnifying glass, you can look at your screen, or maybe if there's sometimes if you get a drop of water on your phone screen, you see the pixels. You can try this at home. I mean, don't put your phone in the water, but if you drop a drop of water, you might start seeing those red, green, and blue shimmer. And that's because each pixel is actually made of 3 components that reproduce red, green, and blue at different intensities. And we can define the intensity of these pixels by giving it a value. And you might be wondering, actually, how do I know what the range of these values are? Because I can write numbers. Let's say this is going to be the red, and this is going to be the green, and but how high can I go? Like, can I write this? I mean, it doesn't complain, and I think it's gonna run. Yep, it does. So yeah, it's much bluer than it is red or green. But like if I write something that's less than this, like this, is it gonna look any different? No, it looks the same. So there's got to be a maximum value, and you can go and find in reference that maybe they don't actually say it in this one. Yeah, they say it in this other function. So the default color space is RGB, so red, green, blue, with each value in the range from 0 to 255. And that's because of ways that the computer works. We're not going to get into that level of detail, but you'll see that in many cases you have values that go from 0 to 255. That's a common thing. So let's go back to our processing sketch. So if I want the maximum value of blue, I can do 255. That's going to be as high as it gets. And I can do less than this, and then we're going to start to see a difference. So now it's green. Because we have like more green than we have blue. And if you want to figure out what color you want, there is actually a color selector in P5, and I can go there, do copy, and see if this works. Okay, it's in hexadecimal value. So here I could copy paste each of the R, G, and B values, or I can actually use this, and I think I need to put it in between those if I use this this type of notation. Not sure. Let's try it. The best way is always to try it. So it doesn't work like that. Okay, so maybe like that. Yeah, like this it works. So I can go in the color selector and pick your favorite color. So what should we pick? Any preference? What's your favorite color? I see a lot of purple in the avatars, so maybe we go with purple. So yeah, some bright purple. Not too bright. Yeah, something like this I think would be nice. All right, so let's go with this. All right, nice purple background. Okay, so is it all right so far? Scream if you don't understand something. So next up, we can bring back our circle, but let's make it a little more interesting. So before we were using numbers. So far we've been using numbers. We've been using these RGB color. This is a different way to write RGB, but this is R. This is red. This is green, and this is blue. It's just written in a weird alien language called hexadecimal, but it's essentially the same thing as what we saw just before. And you'll see actually that some function can take different ways that have accept different ways to give them information. And in this case, we can give it 3 parameters that are red, green, and blue, or we can give it 1 parameter written in the form of a hexadecimal code. That's also how colors are typically written on the web. So we'll see more of that next week. And yeah, so you can pass these values, but they don't change. So what if we want this value to change? Well, we could pass it a value that changes, like, for example, the position of the mouse. And you see that when I type this, so when I type this, it's black, and as soon as I add the X, it goes pink, and that means that processing recognizes it as a valid keyword in the processing language. Processing is not technically a language, it's Java, but yeah, let's say that. So it recognizes that this is part of the recognized words that processing knows about. I can also do mouse Y, so that's going to be the vertical position of the mouse. And let's give it a size, let's say 50, and not forgetting the semicolon always. So now if I run this and bring it in, look at this. I already have a drawing program. All right. So just in those few lines of code, we already created a drawing program. But right now, so it's missing a few things. So first of all, I don't like the way that all of these strokes are always around the circle. It's not exactly how you would expect a drawing program to work. So let's say I don't want those. So how about I say before the circle, I will write no stroke. I don't want a stroke. No, nobody wants a stroke. No stroke. And now if I do it again, you see the stroke is gone, and now it looks more like I'm drawing. Okay, so this is fun. Let's say I want the color of the stroke to be a different color. So what if I want the fill color, it's called the fill, to be a different color. So I'm going to make a mistake right now on purpose to, to teach you something else. So let's say I say fill, and actually it can also take, I think it can take words like red. So if I say fill red, purple and red, it's going to be beautiful. So bright red on purple. Oh no, it's not happy. Maybe that's a P5 thing. It happens. So red and 0 green and 0 blue. Let's stick with the RGB then. Okay, running. Oh, and it works. It actually does work. It does work, but there's a problem, and I need to find a way to show you the problem. So yeah, I know, I know why it works. I shouldn't have done that. So the way that that processing understands things, and let's see, if I draw, if I want to draw another circle, no, let's do another fill, and we're going to do a green. So 0 red, 255 green, and 0 blue. So now we have 2 instructions. So if I run this, which color do you think the circle is going to be? Like my writing tool, what color is it going to be, the brush? That is correct. I believe that is correct. But let's check. So yes, it's green. So what happened to this this other instruction, the red one? So red, and this is green. So what does that tell us about the way that processing understands the code that we give it? Any ideas?
The green color override the red color, because when it's draw, it says it's an update, so it's a new execution process. Then it override the red, so it's green.
So that is somehow correct, but there's a simpler explanation of what's going on, which is the order in which instructions in a program are read. So this is I mean, it makes kind of sense because that's also how you typically read a list, but a list of instructions, like say a shopping list. But you could say, oh, you get a shopping list, you will buy things in any order, like whatever they are stored in the shop or something. But the way that processing reads the code is it starts at the top and then it goes down, reads a line, goes back, it goes down, and it reads it in order. In the case of the draw, it will do it once, and then in the next frame, which is the next sort of update of your canvas, it will go back to the top of the draw, read it again, go back to the top of the draw, read it again, and that's 30 times per second or 60 times per second. Okay, so
I think we can add another circle after the red.
That is a very good point. So yes, absolutely. Yeah, you're totally correct. And that will give us the opportunity to show something else. Yes, I'm gonna do it, and we're gonna, because if I do this, they're gonna be drawn on top of each other. So we're only gonna see the red, and you see the green a little bit in the back. That's that shouldn't be the case, but it is not perfect. So yeah, we see a little bit of the green on the edges, but the red gets drawn on top, and that's because it's reading those instructions in order. You have to think of processing as a very stubborn and rule-obsessed painter that you give instructions to. So if you have this painter and you tell them, okay, I want to draw shapes, but I don't want them to have a stroke. All right, that's fine. Now I want you to pick up the green paint bucket. Okay, and I want you to draw a circle at this position. All right, the painter picks the green bucket of paint and draws a circle in that exact position. Then you say, pick the red bucket of paint and draw a circle in that position. The painter is not saying like, oh, but you just told me to draw a green circle in that same position. It's just going to be drawn on top and you're not going to see the green one. It's not smart in that way. It's just like, well, okay, I guess that's what you want. I'm going to do it. So it's not interpreting. It's not trying to be smart. It's just going to do exactly what you tell it in the order that you tell it to do it. So yeah, or you might think about that painter as a smartass that is just perfectly exactly following your instructions, and if you were unclear, it's just going to tell you, well, but that's exactly what you told me to do, so I did it this way. So you have to be extremely specific in what you're asking the painter to do, because it's not going to try to think about what you meant, but it's just going to do exactly what you said. That's a very important thing to learn when you think about programming. Is the way that your code is interpreted is exactly the way that the code is written, and it's going to very rarely be the fault of the program or the fault of processing that something goes wrong. It happens, but in most of the cases, it's going to be your fault for not specifying things explicitly enough. And it's a humbling and frustrating experience that never ceases. That you discover that you've been dumb again, and that you thought you were asking the computer to do one thing, but actually you were asking it to do another thing, and it did exactly that. So yeah, now if we want to see the red circle and the green circle, well, we have several options. We could make it smaller, and I think that's probably what I'm going to do. So let's make it smaller, run again, and now we have our green circle drawn first, and then the red circle on top. So if I go a bit fast, you're going to see the red circles from the frames before are showing up. Does it make sense? It might still be a little bit confusing, so I'm happy to go over it again if something is unclear. The other way that we could also show it maybe a little better is if I add something to the mouse position. So say mouse X plus 40. So now we're drawing the green and the red next to each other. And you see that the green is drawn after the red, so it always goes on top. Well, yes. Wait, I'm going to show it better. So 30. Run. Yeah, so here you see if I go down that the red is overlapping with the green in this way, right? Because the red is drawn after the green. All right. So what are we going to do next? So one thing, I'm going to remove the red one, and maybe we can get a more interesting color for this. Let's see, tools, color selector. So we could get a light pink that will go nicely with the purple. I'm going to copy this and use it as a color for our brush. By the way, you may have noticed that I added these gray things here. Those are called comments, and the painter cannot see them. So it's like you're writing with invisible ink on the instructions that you're giving, and only you can read it. The painter doesn't see those. So that's where you can add some explanations about what you meant when you wrote the code. That's how you can, sort of document the code inside of the code. And it's very helpful. Another thing you can do is you can use it to, as we say, comment out some code. And that means it's not going to be executed. The painter is not going to see that code. And now it's not going to draw anything, for example, because I commented out the circle draw. And if I uncomment it, now it's gonna draw again. And now we have this very nice thing here. All right. So next up, we could add a little more interaction. Maybe one thing we could do is that we could say that we only want to draw when the mouse is pressed. So this is gonna let us introduce a new thing that is a conditional, or in this case an if statement, because I want to say if the mouse is pressed, then draw a circle, but if it's not pressed, do nothing. Does it make sense? And it's exactly how you write it. So if, I think its mouse is pressed, but we can check that. No, that's not it. Mouse pressed might be it. So if mouse pressed, and this is going to look a little bit like a function. And I'm going to put this inside. So if mouse pressed, let's see if it runs. Run. Okay, so now I'm moving the mouse, nothing happens. Click, and I'm drawing, release, not drawing, click. So now I have a drawing tool. What's missing is I can't erase and I can't clear the screen. I think I would like to have an ability to clear the screen. That would be nice. All right, so let's add this as an option. So let's say, is there a way to maybe use the right click as the delete? It's not the common way to do it. So maybe that's not smart, but I'm gonna see. So mouse press, mouse button. So there's a mouse button function or value. Aha. So yeah. Okay. So if mouse pressed and mouse button is left. That's a lot of new information. Let's see if we can do that. So all right. So what that means. So if mouse pressed and, so we use double and here. So and, that means this condition has to be true. And that condition has to be true as well. And this is mouse button is left. This double equal here means compare this to that. And if this and that are the same, then this whole thing is true. And mouse press here is true if you have the mouse clicked, and if you release the mouse, it's false. So here, this has to be true, and this whole statement here has to be true as well. So this is going to behave the same exact way that it did just now, because mouse pressed just works. But if I press the right button, now it's not drawing. So what I could do is copy this whole thing and say if mouse pressed and mouse button is right, then how about we redraw the background? So background and this color here. And now I'm going to introduce something new again, if that's all right. So let's see. First we do this, and if I right click it, it deletes it. So now I have a way to write stuff, to draw, and right click deletes everything. So all right. Is that okay? It's some decently advanced stuff already. So I would understand if you need a little bit of time or if you have some questions. Just let me know. All good? Okay. So this is probably not the best way to do this. Actually, the way that is probably the best to do this is to do it inside of the if statement. So I can say remove all of this. Say if mouse pressed, and inside of the if we can add another if. So let's say I was giving you instructions to go to a store. So or say like if you're hungry, go to the restaurant. And then once you're there, I could say and if they have pizza, get pizza, or else get a salad. So here, instead of that, it's going to be, so if the mouse is pressed is the equivalent of if you're hungry. And then we know that the mouse is pressed, but now we want to know if the mouse button is left or right. So if the mouse button is left, circle. And there is an else if mouse button is right, then we're going to do the background thing. So we're clearing the background by redrawing, repainting over the whole thing. Okay. So draw. Now it's the same as before, but it's written in a slightly better way.
What if we just write as, right? Not if mouse button right, like only
What?
as. Isn't it enough?
So sorry, can you repeat that? I didn't hear it clearly.
What if we only write as, like as background is that? Yeah, what if we delete that?
Yeah, this will work, except let's try it. So now I can draw, can erase with right,
I think
but I can also erase with middle click.
Yeah.
So now middle click also erases.
Okay. And I have one more question. What if what if we don't write as if but only if mouse button is right? Like why do we need as if?
Sorry. So no, I didn't hear that either.
You can go back to the original with Control Z. As if statement.
So,
yes.
yeah. Okay.
Yeah, I am curious.
Yes. So
what if we delete as? Like, will it work?
What if we delete else? Okay. Yes, this is going to work as well. But so what is so it's more of a let me see what I've made a mistake somewhere. Yeah, we're missing one squiggle. By the way, let me see, is it edit auto format? So here you see actually you see that I'm putting spaces before the lines, and this is a way to organize the code. It would still run if everything was just like this, but it's harder to understand what's going on. So that's why we add tabs. There are programming languages where it makes a difference, but in this case it doesn't. But you can see that this is quite hard to understand, like how this code is organized and what is inside of something else, and that's why we can go to edit auto format, and it will make it put some tabs before or spaces in this case that will organize our code better. So to get back to your question. So this is going to work as well, but the difference is that if I write else if, it will only execute this code, this code here, if this one was not true. So it saves a little bit of performance, which is not something we should be too concerned about here in this case, because it's a very simple sketch. But else if is doing it that if the left button is pressed, then when it reads else, it just skips altogether, even evaluating this condition and running this. It knows that this is true, so this is not relevant anymore. And if the left button is not pressed, then it will check if the right one is. Does it make sense?
Yeah, thank you. It is like optimization and not for not unnecessary checks in this case.
Yeah, exactly. You got that right. So yeah, it's a little detail at this point. It wouldn't be a huge worry for you, but yeah, better to learn it the proper way from the start. There are many details and small things that you will stumble upon in your coding journey, but yeah, you don't have to worry too much about this. It can get quite complex when there's a lot of conditions that are mixed with each other, but I don't want to burden your brains with too much tangles yet to make knots with your neurons. So yeah, now we have
question.
Sorry. Yeah, please feel free to interrupt at any time.
What are the squiggly brackets?
Yes. So what a squiggly bracket does is it tells a block of code. It just basically makes a block of code that is this draw function contains all of these instructions that are between its two brackets. So all of this only exists inside of the draw, and all of this only exists inside of the setup. This is not entirely. This will make more sense once we start talking about custom variables, but it's still yeah, that is what it means. Does that make sense? It might not, because I think it needs variables to make sense.
I think it makes sense, but why are there like those like squiggly opening brackets like inside the void draw? Yeah, like that.
Yeah, so this is because it tells processing that if the mouse is pressed, I want to run this block of code. So it's defining this block of code that is only gonna run if this condition is true. So
Okay.
is the mouse pressed? You're telling your painter, and now the metaphor of the painter breaks a little bit, but I think it can still hold for a little while. So it might be the painter is looking at the mouse and seeing if you're pressing the button or not. And if you're not pressing the button, it's just going to ignore all of these instructions.
Okay.
As if I told you, if you're hungry, do this and that and the other, but you're not hungry, so you're just going to ignore all my list of instructions. Does it make sense?
Yes, thank you.
Cool. So if it does, feel free to tell me, because I know sometimes those things can be really complex to understand. So I'm totally fine repeating it as many times as I need to. So yeah. What I wanted to say is, yes, so variables, we were talking about variables. So all of these things, this, mouse pressed, mouse button, mouse X, all the pink things here are variables. And what variables are, they are like, you can think of them as mystery boxes with a label. Well, it's not such a mystery because there's a label on it. So a box with a label on it. And if you look inside the box, there is a value. And this value can be a number, it can be a word, it can be a sentence, it can be true or false. There are different kinds of variables. But essentially what they are is this kind of container with a label on it that has a value. And this value can change. So the mouse pressed box, so your box with the label mouse pressed on it, when you open it, you might read true or you might read false, and that will depend on whether the button is pressed or not, or a button is pressed on the mouse, any button. And these are variables that are built in. They are variables that depend from processing. And if you want to, but sometimes you want to make your own variable. And one case when you might want to make your own variables is if you're reusing something several times in your code. And there is a thing that we're reusing so far, which is the color of the background. See, we're reusing it here. We're using it in the setup, and we're using it here when we clear. And say I wanted to, I was going to change this to be a different color. And say, oh, I want a different color background. Or let's leave it here. So I want a different background. I'm going to do a red background with a little bit of green and blue still, just so it's not pure red. So I have my red background. I can draw my pink on it. And now I clear. And it's clearing with the pink because it's still, with the purple, sorry, because it's still there, right? So I would need to go here, copy this, paste it there. And now it will behave the way that I want. So I'm drawing and now I clear. But if I want to change the color again, it's just kind of annoying that I have to edit it in different places. That's not convenient. The reason why we're using a computer and we're writing a program is so that we can be lazy and not have to think about changing things and doing things several times. We want anything that is repetitive, we want the computer to do it for us. So instead of writing the values and the parameters here and there, what I can do is to say I want a variable which is going to be, in this case, it kind of depends, but let's say we will make a color. We call it background color. So we're declaring this box, and we're making this variable, but it doesn't contain anything at this point. And in the setup, we're going to say background color equal new color, and give it this value. Color, is it like this? Might be, or maybe it's just color. Yeah, I think that's how it works. So background color equals color and these values. So now I also need to use it. So we declared it, we gave it a value, and now we want to put it in the places where we're going to use it. So background color. So I draw here. I have my background, I can draw, I can erase, and it's the same. And now if I change it here, say I add more green and run it again. Now we have a nice yellow. Yellow and pink, that's not bad. And if I erase, it's also yellow. Right? Does it make any sense? Making abstract art now. Cool. Okay, so this is nice, but it's kind of missing something. So I mean, you might be wondering, okay, but I can do this with Photoshop, I can do this with Procreate, I can do this with Illustrator. I don't really see what the big deal is with creative coding, and that's where creative coding gets interesting, and also because of these variables. So, and by the way, we were talking about scope. This is where it makes sense. So I declare the color here, so it exists everywhere in the code. If I was declaring this color in the setup, and we're going to do this just now, just so you see what's going on, I'm going to comment this out so it doesn't count, and I'm going to declare it here. Here it complains. It says background color cannot be resolved to a variable. And what that means is that in this block of code, background color, the variable, does not exist because it was created in another block of code. So this is why we declare it outside of the setup, and this is what is called the global scope. So each of these, when I'm talking about block, the official term is a scope. So that is the place where variables live and die. And outside of this, if they haven't been declared as a global variable, they don't exist. So here, this variable lives in the setup, and when the setup is done, this variable just disappears. It doesn't exist for the draw. Does that make sense? I'll consider that if nobody says anything, it makes sense. Okay, so instead of this, we're going to declare it as global, and then and then it works as expected. All right, so now I want to make this a little bit more exciting. And how much time do we still have? 30 minutes. Maybe I'll take 20, and then we can have 10 minutes for questions. I mean, I'm not super strict on time, so if you want to stay a bit longer and ask questions, we can also do that. But I might need to take a break at the end to grab a snack. But we can have an after party if you still have time. So background color. Okay, so what I want to do is to create a float variable. And a float is, I'm going to be calling it the diameter, or maybe actually I'm going to call it brush diameter, so it's a little clearer what it means. It's going to be very helpful if you give your variable names your variables descriptive names, because then you look at the box and you know what's in there. If I called it like, I had a friend the friend who initially taught me programming was he's a great friend, but he wasn't a great teacher at the time. And so he would name all of his variable like bolo, and it's like, yeah, it doesn't matter. You we don't need to give it a proper name. It's just working for there and that blah blah. And I think, but I don't understand. Like, what does it? It's true that it doesn't matter in the sense that you can give a variable any name that you want, except if it's a keyword that already exists in the language. So I don't think I can call the variable setup, for example. It's not complaining right now, but it might if I try to run it. No, bizarrely it doesn't. But I think, well, probably I can't call it float. Yeah, there it doesn't. It's not happy. So I can't say, oh, I want a float variable that's called float. That doesn't work. But yeah, I'm gonna call it brush diameter because it's clear what it means. And if I look at my code again in 2 years or in 10 years, I will still be able to understand what it means without adding a comment that says this is the diameter of the brush. You can do that, but this is a lot more work, and it's just as simple to call it brush diameter and be done with it. So brush diameter, I can actually give it a value there to start with. So let's say we start with a 50 diameter. And right now I'm not using it, but I'm going to go and put it in my circle function here. So now if I run it, it still has a diameter, but it's defined here at the top. And I can change it here. And now it's bigger. And here, it's just as if I was telling my painter, okay, instead of giving the painter a value and saying like, okay, here you draw a brush that is a circle that is 50, I tell it, you draw a circle that is brush diameter. And what that means is I pass the painter the box with the label brush diameter. The painter opens the box, reads what's inside, finds that it's 100 pixel, and now it knows that it has to pick the 100 pixel the 100 pixel brush and use that to paint. And but what's fun about this, and now is becoming the real creative coding part of this. After 1 hour, we're finally getting to creative coding. So the creative part of it and the fun part of it is that this variable doesn't have to be 100 forever. It can change. And I could say in the draw, brush diameter is gonna be getting bigger. So I can say brush diameter plus equal 1. That's a weird one, isn't it? So plus equal. So here we do equal. That's kind of well, it's not self-explanatory, but it means that whatever is on the right side of the equal, you put inside of the box with that label, right? I think that can be sort of self-explanatory, even though if you see it for the first time, it's still a little weird because that's not the way that it works in mathematics that you learned at school. You're saying like, oh, if this is equal that, it's just we're just telling that this is equal that. That's not what this is. This is actually an operator. We call this an operator that picks the value that's on the right and puts it inside the variable that's on the left. But here we have another operator that is plus equal, and plus equal takes the value that's on the right and it adds it to the value that's already inside of the box. So it's just as if, we had 100 apples in the box and we tell it add one more apple in there, except it's not apples, it's size of the brush. But processing doesn't care what you use it for. It's just numbers. So it's just gonna add this to it. So yeah, this is cool. And what it's gonna do is it's gonna add 1 pixel to the size every time we run through the draw. So 30 times per second. Might be too much. Let's see what it does. So now it's getting bigger and bigger and bigger over time. Okay. Yeah, it's already too big. So let's say we want to add a little less over time. So I can, because I made a float variable, I can add, instead of 1 pixel, I can add 1/10 of a pixel every frame. This might be a little better. So let's try that. So you see, it's increasing in size over time. Okay. It's a bit hard to see because we're overwriting everything. But one thing we could do is we could also change the color of the brush over time. So let's say I'm gonna add another color variable, brush color, and the brush color right now is here. So I'm gonna take this, write brush color in the fill. Remember this, the fill is the instruction where you tell the painter, pick this bucket of paint that has this color. And instead of saying pick the bucket of paint, we just say pick the box that has a bucket of paint in it. It sounds convoluted, but that's going to be very helpful for the future. So here we say brush color equals color, this color, and this. One thing I recommend is when you make a change to your code, it's always good to first make the change that actually just does the same that you were doing before, but in this optimized way that you want, and then try it to make sure that you did it right. So here it's still the same. I didn't make any changes to the behavior of the code, but I'm checking that I didn't make a mistake. And then I can start making other changes. So this way you check yourself, basically. If you make 2 changes, then run the code, and then there's a bug, you don't know if it's change number 1 or change number 2, or in the worst case, you made 10 different changes to the code and you have no idea which one introduced the bug in the first place. So it's good to always run when you make a small change, to always try to make a change that is that doesn't necessarily make a difference in the moment. Run, test, then make the change that actually makes a difference. So here we have this color here, and what I want to do is actually, I'm going to discard entirely this first color, and I'm just going to say brush color equals color. And yeah, I think I can probably comment this one out, but we're just going to overwrite it for now. And we can't do plus equal here because it's a color and it doesn't have this. But there's an interesting variable that I use a lot in processing that is called frame count. And what frame count is a value that is the number of the frame. So 30 times per second processing runs the draw, and every time it does that, it adds 1 to that value. So the first frame is 0, the second frame is 1, etc., etc. So if I do frame count for the red and 0, 0 for green and blue, we're going to have a color for the brush that starts just, black. 0, 0, 0 is black, or you can also just write 0. And the value of the red is going to increase. Actually, you know what? I'm just going to do color frame count, and this is grayscale. So if I do 0, let's see. So if I do 0, it's going to be a black brush. I'm just going to show you that. So you see I'm not lying. So now we have a nice black on yellow, high contrast, very nice. If I put 255, it's going to be white. And if I do frame count, it's going to start black and it's going to slowly get white. And then it's going to crash because, because it's going over 255 and that doesn't exist. So we have a problem, which is that after the 255th frame, a color is out of range. So there is a very, very useful operator in programming, especially for creative coding, that is called modulo. And modulus or modulo is, well, if you want to get technical, it's a remainder of the division. And if I do modulo 255, you don't have to think too much about the mathematics of it. All that does is that when we get over 255, we go back to 0. So that would be the equivalent somehow to write int, so an integer, so whole number, int animation variable, animator, let's call it animator, equals, so I could do the animator is equal this, or animator equals frame count, and say, no, this is actually not going to work. So yeah, let's do it like this, animator. But it would be as if we reset the animator to 0 every time we get over 255. So it's going to keep looping from 0 to 255 and back to 0. Not all the way back, just immediately back to 0. You'll see that in a sec. So let's try it. So now I'm going up to white and boom, it goes back to black and all the way to white, back to black. And this might not be what you want, but this is what we asked the program to do. So that's what it's doing. I can do a bagel. It's not a very tasty looking bagel, is it? Or maybe if you're into this, black food trend, that was all the rage a few years ago. Okay, so this is working. And another interesting function that we use a lot in creative coding, or at least I like to use it a lot, is the sign function. And sign function, I feel like the sign function is unfortunately, so it's this whole trigonometry thing. Probably saw this in math class. I was terrible at math. I know, when you grow up, they tell you like, oh, you have to learn math because if you want to do programming, you have to be really good at math. That's not true. I was horrible at math. It's a whole entirely different way to think. It's it helps if you have a good level in math. Don't get me wrong. You're gonna have a leg up in creative coding. But if you always hated math and you think you're really bad at math, it doesn't matter. It really doesn't. So don't be worried about that. But I feel like trigonometry is really not explained the way that it should. Or at least it was the case when I was in school. I don't know about you, but I feel like if we were shown this GIF in school, you would save a lot of time. So basically, what a sign function does, I could watch this for days. So what a sign function does is it takes an angle as an input, and it gives you a value as an output that is between -1 and 1. So as the angle goes up, the value keeps oscillating between -1 and 1. And you may realize how useful that can be for all kinds of things, because you have a value that keeps oscillating and you can use it to have things that grow and shrink all the time. It's lovely. So this is extremely helpful, and we can use it everywhere. So we don't have an angle, but what we do have is frame count, which is a value that goes up, and the angle can keep going up. You know that angles go from 0 to 360, but actually it can keep going and wrap up on itself. It doesn't matter, because as you can see, it keeps, once it goes all the way around the circle, it gets back to the beginning. So 360 and 0 are the same angle in a way, at least as far as the sine function is concerned. So let's stop being abstract about it and just use it. So I'm going to do this. And we're going to have a problem, which it says like cannot convert float to int. And this will happen because the sine function returns gives us as an output a number that has decimal value. So it's going to return like 0.0 something like that. Or no, not 1. It's not going to return that. So it's going to return a value like this, and here animator is an int. So we're going to make it a float, and that should solve this. Okay, and now what you see is it stays black, even though our animator function, or sorry, our animator variable is used for the color. It stays black. And why is that? Well, there's one way that we can try to figure out what the value of animator is. Because that's going to start to become a problem if we have a lot of variables and they don't do what we want. We want to look into the box all the time and check what's in there. Not with colors, not with anything, but actually see the number. What is this number? Is it this? Is it something else? I don't know. So the way that we could do this is to say print, or print ln, that prints a line, animator. So let's just say print. I think it's going to be fine. So what print does is it prints the value in the console at the bottom. We haven't really looked at this part very much, but as the program runs, for each draw loop, it writes the value here. And you can see like they're all written on the same line, so that's a bit inconvenient. So we're going to say print ln, that prints a new line. Okay, and now I see that the values are going from, minus 0.9 something to 0.99 something. It's not obvious, but you get a sense that at least it's not going from 0 to 255, which is a problem. So there's a divide by 2. So now it goes from 0 to 1, and I'm going to multiply it by 255. This works, but it's a little complicated and hard to understand. But I can show you that it's working. It's oscillating between white and black very fast. A little too fast. We could change the speed, but I'm going to do this after I explain you the easy way. The easy way is to use another function, and we can wrap this sine function into this other function called map. And map expects different parameters. So let's look in the reference. It expects more than one parameter. So it takes a value. Yeah, it takes a value. It takes and it takes two ranges. The input range and the output range, and it remaps the range from one to the other. So we know that we have a number that goes from -1 to 1, and we want a number that goes from 0 to 255 because that's what a color takes. So if I go here, I can say, okay, this is the lowest value of the input range. This is the highest value of the input range. And this is the lowest value of the output range that I want. And this is the highest value of the output range. And that's as if you had, a ruler that goes from -1 to 1. You move it a little bit to the right, and then you stretch it up until it's 255 value long, like number. The unit doesn't matter in this case. I hope that makes sense. It's if it's getting complicated, just be happy that we're almost done. As I said, I will give you resources to go further. I'm just taking you through a little bit of the process that I might use to create to create a generative piece of art. So here we have something that lets us do these nice sort of sandworms. I think it's a bit too fast, so I could say I want to reduce the speed by dividing the frame count by 10. So that doesn't mean that the frame count, like that the frame rate of the sketch is going to be slower, but it means that the variation here is going to be slower. And here we have a problem, which is that I'm dividing with using an int. So it's an integer, so it's going to turn it into an integer. So I'm going to make it a float by adding a decimal value, and I think this should solve it. You might find these issues that things don't look smooth when you think they should look smooth, and that might be because it automatically converted your float to an integer. So your number with a decimal value to an integer, and that happens when you add a number that doesn't have decimal values, and automatically it just switches it to the other kind of numbers, and yeah, that's not what you want. So I'm adding this. I could also, and that's usually what I do, so I don't usually get that problem, multiply by 0.1, and that makes it smaller. By 10, that divides it by 10. That's the same thing. So here you see I have a much smoother variation. Okay. Yeah. Well, we're almost hitting our hour and a half mark, I believe. So now, if you have some questions, I'm open for it. And yeah, we already covered a lot of ground. I hope you're not too overwhelmed with new information. There are tons of resources that I will share with you where you can go and learn more. So even if you got a little lost towards the end, I hope not, but that would be totally understandable, and you will be able to go back and understand the basics again. But yeah, 1.5 hours is very short to get to learn programming. So this is more of a taster platter. Yeah, how was it for everybody? I hope it was you still learned something. Let me know. Is everybody still there? Yes, absolutely.
I just wanted to ask, when are we going to look at the workflow, like how to get that stuff into Hiketnunk? Like
next Monday.
Okay.
So next Monday I will cover. So I have a question for you actually. Have you already had instructions on how to mint on Hiketnunk at all? Like just an image? Or is it something that you're going to see in another workshop, or should I cover this next week?
I think all of
No, most people know how to mint. I think everybody knows how to mint on Hiketnunk here. Yeah.
Okay. Yeah, so next week I'm going to cover how to mint interactive NFTs on Hiketnunk. So if you've been on Hiketnunk before, you've probably seen those. They are the ones that have this little icon on the top right. And yeah, I make some of them, and I'll explain to you how to make those. So this is like fairly close to a GIF. It doesn't have a lot of variation, but you can go and make some more interesting or things with more variations at least. Like, for example, this one that is responsive. So it works on different screen formats. It also includes its own source code. That's not something that Hiketnunk does by default, but I included it. And it also changes. It has different color palettes that you can cycle through. So this is, yeah. So I'm not promising that you will be able to make exactly this kind of work by the end of 1 hour and a half next week, but I will show you the basics of how to get from this kind of sketch, except it will be in P5.js, and put it on Hiketnunk in a way that it runs in the browser, so it can, for example, look different for each person that looks at it. which is the case for this one. If you go to, I'll find the link. Let me see. Where is the residency artist? So if you go to this link, you will see that each one of you, well, you might not see it because it's just going to look different for each of you, but at least if you're synced. So if you're synced, you will see a different color palette and a slightly different pattern, each of you. And this is something that we'll cover next week. So yeah, I hope that answers your question.
Yep, cool. Thanks.
I think Octavio had a question which I didn't see before, which is what is the difference between using the editor of processing or the editor of P5.js?
Yes, so processing is meant to run on your machine. P5.js is meant for the web. So if I run the P5 editor, I can share the sketch and it's going to run in somebody else's browser. I can export it to run inside of Hicketnunk. It takes a little more work to do that, but I will show you next week how that works. And with processing, you would typically more export a static image or a video or a GIF. There are tutorials for all of these that I will link, and if you need something specific, you can ask me, and I will send you some tutorials and some links where you can find what you need. But typically, you will find a lot of information on the forums. All the links are going to be in this document that I prepared for you. So with some explanation how to get started, some basic tutorials, people to follow on YouTube and Twitch, books, podcasts, interesting videos about creative coding in general, and some communities that I can recommend you join to find other like-minded people. So yeah, you'll find all you need there. But yeah, if we wanted, for example, to say if mouse button equal middle. I hope this works. No, is it center? Yeah. Oh, not sure actually if that's correct. Let's see. Find reference. Yeah, center works. So if I press the middle button. So if I press the middle button, I can say save frame there. And so now if I run it, I draw something, I press the middle button, nothing happens. Let me double check. I think it should work normally. Yeah, well, okay. That doesn't work, but no, you should be able to send. Maybe I made a mistake. Okay. Save frame. Let's see. Here it should want to save a frame every time. Oh no, I know it's actually saving it. I just didn't. It just doesn't tell you. It was saving it. So yeah, it saved. It saved a lot of frames. And actually, that's a good one. If you want to know where your sketch is and where it's going to save the frames, you can do File, and no, not Sketchbook. With Control K. Oh, Sketch. Sorry. Sketch, show sketch folder, or Control K or Command K on the Mac, and it will open the folder where your sketch is. That is the sketch, and also you have all the frames that you exported. So let's say I delete all of those. So now I have my sketch here. If I redo my middle button scheme here, I save it and run it. So I have it here. Let's look at the folder. So we see what happens. I draw something, and then I click the middle button. And for, yeah, unfortunately, for the whole time when the middle button was pressed, which is several frames, it saved each of them. There are ways to do this, but yeah, just to show you. So I can take this and mint it on Hicketnung. Or there are ways to export videos as well. There's a whole tutorial about that on the YouTube channel, The Dot is Black, which I definitely recommend watching if you're if you're looking to make videos. So yeah, video export. He made a 4-part video on 4-part tutorial on exporting videos from things. So let's just watch it if you're into that. And I'm losing my voice. All right. Any other questions? Everybody's stumped.
Thanks,
All
Raphaël.
right. Well,
I have a question.
Yeah, go ahead.
Sorry, go ahead.
I have a question, but it's more complex, so maybe I can ask it privately. Like, I was wondering about some GIFs made with processing, and they are like perfectly looping, you know, like some particles moving to the center.
Yes.
And it's like, but maybe not the case here right now.
Yeah, exactly. That's a very interesting one. The typical way to do this is to use what's called a Perlin or polar noise loop. And I can recommend another resource is also in the Notion page here, which is something that my friend Taru created and I contributed to as well, which is that creative code page. That creative code page, where you have a lot of commonly used creative coding algorithms and techniques. And one of them is a Perlin noise loop. And here you have a tutorial about this. And yeah, that's a great way to create something that returns to the same state after a number of frames. So yeah, you can find this there. No, that's a very good question, actually. And maybe, yeah, if we have time, I can cover it next week. But it's a little, like you said, it's a little more advanced. So that might be tricky for some to understand. But I can definitely go over this. Yeah. Any other questions?
Thank you very much.
And of course, you can always write to me if you have further questions or if you don't feel like asking on voice.
There's just one question from Kukusum. He says, I really wonder how long it took you to learn coding and whether you use it for creating NFTs of something else.
Yes. So, well, yes, I do use it to create NFTs. I started on I checked recently, started on the 6th of March, I believe, were my first NFTs on Hicketnung. I knew of NFTs before, but I didn't want to do proof of work. And so I was waiting for proof of stake. And yeah, this was my first one, and it was made with P5. But it's a video actually. And yeah, it was wait, no, 4th of March. My bad. So yeah, Hicketnung opened on the 1st of March, and and I jumped on it 3 days later. So yeah, all of my NFTs except this one and that one I made with P5 or processing. So these are GIFs that I used to make, that I made in 2017. I have a whole series of those, with this one probably being my favorite that was done in processing. And yeah, those are the kind of perfect loops that you were talking about. Yeah. So yeah, I do use creative coding for this. And the other part of the question, I think, was if I use it for something else. And yeah, I've used it for prototyping in my design work. A lot of people use this also for creating dynamic visual identities for brands or things like that. You can use it to create interactive visuals for apps. It's getting more common that apps have this kind of interesting backgrounds that change depending on the state of the app, and you can do this with creative coding. So yeah, it has other applications besides NFTs, also interesting websites. But it's a whole world. I shared in the Notion page. You will see. Actually, I'm going to share it now. Let's share to web. Copy link. So you can go and check it out. Yeah, you have a lot of videos there where you will see people who have been using creative coding in their work. You can also output it to. You can also make plotter drawings, which is also something that I've done in the past. It's it's a very broad field, and it's impossible to cover it all in just an hour and a half. But yeah, hopefully, if that's something you actually want to explore further, you will find directions where to go and some interesting books that I recommend also to check out. Code as a creative medium is probably the most the broadest, and it covers. It also shows a lot of different works by different artists, so you can find some inspiration there, plus some coding exercises. And yeah, that was a long answer to a short question. I apologize. All right.
Okay, thank you so much. This was great.
Yeah. You're welcome.
It was amazing. I saw you already shared lots of resources, so thanks a lot. And I think we all look forward to the second class.
Yeah, and feel free to start exploring on yourself with the resources that I shared. If you're trying, if you're starting to play around and prototype things by yourself, and you're hitting some issues, send me a DM. I'll try to reply as fast as I can, and then yeah, we can look next Monday on how to put those onto Higetnung.
Great. Thank you so much. Bye, everyone.
Yeah. Bye, everybody.
Bye.
Thank you. Bye.
Thank you.
Bye-bye.